Hello dear students, welcome to Konar classes. So in this session we are going to solve some questions on binomial theorem. So most importantly, you also do along with me write down the question the way I am writing, followed by you also start solving as I start explaining. Okay, thank you. So first question, let me take it from my notebook. The question is, find the term independent of x. Find the term independent of x in the expansion of let me write it here, expansion of three by 2 x square minus 1 by 3x to the power 6. Okay. So let's proceed, dear students. So if you see this expansion, how many terms are there? There are 7 terms, 6 plus 1, because the power is 6, so there are 7 terms. Now out of these 7 terms, there is one term in which there is no x. That means that particular term is independent of x, and according to the question we need to find that term, the value of that term, and we are going to solve it. So dear students, let's look into it. Let's assume that let t r plus 1th term be the term which is independent of x. Okay. So then what is t r plus 1? T r plus 1 is equal to 6 cr into 3 by 2 x square power 6 minus r into minus 1 by 3x power r. Correct? That is the r plus 1th term. Now if we simplify it, what we are going to get, this is equal to 6cr into 3 by 2 power 6 minus r into x power 2 into 6 minus r into minus 1, so here minus 1 power r into 1 by 3 power r into 1 by x power r. Okay. So if you see that I am separating the term that that constant term and the variable x. So now if we bring all these constant term in one place, so what we will get, 6c2 into 3 to the power 6 minus r, and here it is 1 by 3 to the power r. 1 by 3 to the power r means what? 3 to the power minus r. So 3 to the power minus r and 3 to the power 6 minus r. That means 3 to the power 6 minus 2r. Correct? Into 1 by 2 power 6 minus r. 1 by 2 power 6 minus r into, there is a minus 1 power r, and that we can write in the left here. So we can write minus 1 power r. And what is the power of x, dear students? So here we get x to the power 12 minus 2r. 12 minus 2r, and here it is 1 by x power r, that means x power minus r. So here we can write x power minus r, so 2 minus 2r minus r, it becomes minus 3r. Correct? Now dear students, if you look into this question once more, that we need to find the term which is independent of x. That means this term should not be there, means x should not be there, very precisely to say. That means the power of x must be 0. Correct or not? So that means this entire term can be independent of x if the power of x is 0. Power of x is 0 means what, dear students? 12 minus 3r is equal to 0, and from here we get the value of r is equal to 4. So what we can say, dear students? So we can say that t 4r plus 1, that means 4 plus 1, that means the fifth term in the expansion of this is independent of x. And according to the question, we need to find that term. What is that term then? Okay. So let us find it out. So if we apply r equal to 4, then we get t5, the fifth term, r equal to 4. So minus 1 power 4. Okay. Then, oh sorry, here it is not 6c2, it is 6cr. Okay. And 6c4 into 3 to the power 6 minus 2 into 4, that means 6 minus 8. Okay, 6 minus 8 means 3 to the power minus 2. 3 to the power minus 2 means 1 by 3 to the power 2, correct? These are very, simple, calculation. 1 by 3 to the power 2 into, okay, 1 by 2 power 6 minus r, that means 1 by 2 into 6 minus 4, that means 1 by 2 power 2, that means 1 by 2 to the power 2, correct? And this term to 1. So whatever the value of this expression is the answer to this question. So minus 1 power 4, that is 1. So 6c4 factorial 6 divided by factorial 4 into factorial 6 minus 4, that means factorial 2, into what we get, 1 by 3 square, that means 1 by 9, into 1 by 2 square, that is 1 by 4. So what we get it here, dear students? So 6 into 5 into 4 factorial divided by 4 factorial into 2 factorial is 2 into 9 into 4. So this 4 factorial and 4 factorial got cancelled. So this 2 and 6 got cancelled, we get 3, and this 3 and 9 got cancelled, we get 3 here. So we get the answer, this is equal to 5 by 12. So dear students, the answer to the question, the term independent of x in the expansion of 3 by 2 x square minus 1 by 3x power 6 is 5 by 12. Okay, so this is the answer we get. I hope it is very clear to you, dear students. Now let's proceed to the next question. Okay. So next question, let me write it down from my notebook. Okay, let me write it down. The question is question number 2. Okay, if the coefficients of a to the power r minus 1 comma a to the power r and a to the power r plus 1 and a to the power r plus 1 in the expansion of expansion of 1 plus a power in or in arithmetic progression prove that n square prove that n square minus n into 4r plus 1 plus 4 into r square minus 2 is equal to 0. Okay. So let's look into this question. So dear students, so what is mentioned in this question is that the coefficient of a to the power r minus 1, a to the power r and a to the power r plus 1 in the expansion of 1 plus a power n are in arithmetic progression. So first of all, dear students, so what we need to do, we need to first see the the terms in the expansion of 1 plus a power n. So if we look into 1 plus a power n, 1 plus a power n, if you recall dear students, I discussed this thing in our previous class, that is equal to 1 plus nc1 into a plus nc2 into a square plus nc3 into a cube. In that way it will continue. The last term will be ncn, or we can consider the r plus 1th term should be ncr into a power r, and in that way it will continue. The last term will be ncn into a to the power n. Correct? Now the coefficient of, so what is the r plus 1th term, dear students? If we look into the r plus 1th term, if we see the tr plus 1, that is equal to ncr into a to the power r. Correct? Now coefficient of a to the power r is what? ncr. So the coefficient of a to the power r minus 1 will be what? ncr minus 1. Correct? So what we can write is that, so from here we can write that coefficient of a to the power r is equal to ncr. Correct? So coefficient of, so in the same logic, if you see this pattern, we can write the coefficient of a to the power r minus 1 is equal to nc r minus 1, and coefficient of a to the power r plus 1, in the similar manner we can write that coefficient of a to the power r plus 1, that is equal to nc r plus 1. Now dear students, according to the question, these coefficients, that means this one, then this one, then this one, these three terms are in arithmetic progression. First this one, then this one, first this one, the coefficient of a to the power r minus 1, let me write it down. So from here what we can say is that according to the question, ncr minus 1, then ncr and ncr plus 1 are in arithmetic progression, AP, I am writing it down. So then what we can write, dear students, from here? From here we can say that ncr minus 1 plus ncr plus 1 is equal to 2 into ncr. Correct or not? So what we can write? So from here we can write that ncr minus 1 plus ncr plus 1 is equal to 2 times of ncr. Now from this relation we need to prove this one, that n square minus n into 4r plus 1 plus 4r square minus 2 equal to 0. Now how to proceed? So if we see this thing, dear students, so what we can get here is that there is a formula, okay, from combination, and I am writing this formula here. We need to make use of this formula. The formula is that, if you recall, ncr minus 1 plus ncr is equal to n plus 1 cr. We can make use of this formula. I repeat, NCR minus 1 plus NCR is equal to n plus 1 CR. So we can apply here. So how we can apply here, dear students? So we can write that NCR minus 1, we are adding one NCR, okay, plus we are adding one more NCR plus NCR plus 1. So that means 2 NCR we have written in the left hand side. So we need to adjust that. So we should add 2 more NCR in the right hand side. So already 2 into NCR is there. If we add 2 more NCR, so it will become 4 times NCR. Correct? Now, as we just discussed this one, that NCR minus 1 plus NCR is equal to n plus 1 CR. So from here we can write n plus 1 CR plus, if you look into it, NCR plus NCR plus 1, and use this formula just by replacing R by R plus 1. So then what we get, n plus 1 CR plus 1. This one, if in this formula, if we replace R minus 1 by R, then what we get? So R minus 1 will become R and R become R plus 1. So where you get is that n plus 1 C R plus 1, correct? N plus 1 C plus 1, correct? 4 into NCR. Correct, dear students? Let me explain once more. Here we see that NCR minus 1 plus NCR is equal to n plus 1 CR. Instead of R minus 1, if we write R, or we can say in one way, instead of R, if we write R plus 1, then it becomes NCR plus 1, and here it will be NCR, because instead of R we are writing R plus 1. So that comes into this expression, and then what will be? It will be n plus 1 C R plus 1, correct? So now we need to simplify this. So how to simplify this? Let's look at in the here we can write, this implies n plus 1 factorial divided by R factorial into n plus 1 minus R factorial, n plus 1 minus R factorial, plus n plus 1 C R plus 1. That becomes what, dear students? N plus 1 factorial divided by R plus 1 factorial into n plus 1 minus of R plus 1 factorial. That means we can write n plus 1 minus of R plus 1, R plus 1 within bracket, this complete factorial, correct? That is equal to what, dear students? We get 4 into NCR, that means n factorial divided by R factorial into n minus R factorial. Okay, so now let's first simplify this. If you remove this bracket, then it will become minus R minus 1. So let me remove this bracket. So what we get, dear students? So we get it here minus R minus 1. So we can give the first bracket. Now this plus 1 and minus 1 get cancelled. So what we left with? N minus R. So let us write it down. Instead of this thing, so let us write it down. Here it is N minus R factorial. Okay. We are matured enough on permutations and combinations, hence we are writing in the same step the simplification. Now, dear students, what we get is that n plus 1 factorial, what we can write? We can write, we know that n plus 1 factorial is equal to n plus 1 into n factorial. So what we can write? We can write n plus 1 into n factorial. Here also n plus 1 factorial, we can write n plus 1 into n factorial. In fact, we can write it within bracket, and here already n factorial is there. Now, dear students, what we see in the left hand side, in the both the expressions, n factorial is there in the numerator, and right hand side also n factorial there in the numerator, so we cancelled it. Now, dear students, what is R plus 1 factorial? It is R plus 1 into R factorial. So instead of r plus 1 factorial, we can write r plus 1 into r factorial. Now in the left hand side, this r factorial in the denominator, this expression, r factorial in this denominator of this expression in the left hand side get cancelled with the r factorial in the right hand side. Okay, so now the simplified equation we can write it here in the left part of the board. So what we get, dear students? So now we see that n plus 1 in the numerator in the first expression of the left hand side, in the second expression of the left hand side also n plus 1 is there in the numerator. So we can take n plus 1 common. So if we take n plus 1 common, then what we left with, dear students? We get 1 by n plus 1 minus r factorial. So we get 1 by n plus 1, or we can write n minus r plus 1 factorial. Okay, plus what we get, n plus 1 already we took common, then in the denominator we get r plus 1 into n minus r factorial plus 1 by r plus 1 into n minus r factorial. This is in the right hand side. What we get, dear students, that 4 by n minus r factorial, 4 by n minus r factorial, correct? So now let's look into it, the simplification. Let me clean this portion. Okay, so what we get, dear students? So n minus r plus 1 factorial, that is nothing but n minus r plus 1 into n minus r factorial, because we know n factorial is equal to n into n minus 1 factorial, using that concept. So instead of n minus r plus 1 factorial, we can write n minus r plus 1 into n minus r factorial. So instead of here with this, we can write n minus r factorial. Now this n minus r factorial in the left hand side of the denominator first expression, n minus r factorial in the denominator of the second expression in the left hand side got cancelled with the n minus r factorial in the right hand side expression of the denominator, correct? Now all this factorial we are able to cancel, because factorial of any number cannot be equal to 0. So then what we get, dear students? So from here we get n plus 1 into, here we get 1 by n minus r plus 1 plus 1 by r plus 1, correct, is equal to 4. Now if we simplify this, we will get this one. Let's see how. Okay, so from here what we get, dear students? So n plus 1 is already there in the, it is the common. Then we take an LCM of n minus r plus 1 into r plus 1, correct? Then we get it here, r plus 1 plus n minus r plus 1, correct? So that is equal to 4. So now r and minus r got cancelled. So what we get in the numerator, 1 plus n plus 1, that is n plus 2. So what we get here, dear students, that n plus 1 into n plus 2 divided by r plus 1 into n minus r plus 1 is equal to 4, correct? So now if we continue in the right hand side, in the right side of the board, what we can get, let's see. Okay, so from here I want to continue here. Okay, so let me clean this portion. So what we get, dear students? So let's make 4 into, so from here what we get, 4 into r plus 1 into n minus r plus 1, n minus r plus 1, that is equal to n plus 1 into n plus 2, n plus 1 into n plus 2. So what we get, dear students? So this implies, let me give this as a separator. So 4 into, what we get, r into n, so rn, okay, minus r into r square, plus r into 1 is r, plus 1 into n is n, minus 1 into r is minus r, plus 1, okay, that is equal to n plus 1 into n plus 2. So n into n, it is n square, plus n plus 2, it is 2n plus 1n, it is 3n plus 2. Correct? So now, dear students, if we see that plus r and minus r got cancelled, so what do we get here, dear students? So this implies, so let me use a different color, okay, because in the left hand side of this board it is in the blue color. So this implies, dear students, what we get? We get 4rn minus 4r square plus 4n, okay, plus 4 is equal to n square plus 3n plus 2. Okay, so then what we get, dear students? So we can write, if we make into the same side, so we make n square. Now 3n minus 4n, that means minus n, okay, then minus 4rn plus 4r square, and plus 4 when we bring into the other side, so it becomes minus 2 is equal to 0. So 4r square minus 2, so you already get. So our target will be to prove this one. So we need to prove this one, correct? So then n square is there. So that implies what, dear students? So we get n square, then minus, if we take n common, then 4r plus 1, between these two terms, minus n minus 4rn. So we took minus n common, then from here 4r and from here 1, so 4r plus 1, plus 4r square minus 2, that is equal to 0. And we are able to prove what has been given, okay. So with this note, let me conclude the session here. In the next session, means it is the second part of this session, we will solve 2 more questions. In that way, in few sessions we will solve some good amount of questions. Thank you very much. Bye.